In this question, we've been told that a small box of mass 15 kilograms is being pulled by a rope inclined at an angle of 50 degrees to the horizontal, and this is along rough horizontal ground. Okay, I'm just going to produce my own diagram as usual. I want to make sure that I can freely annotate and add all the forces that I might need to consider. So the weight of this box is 15g, and we know that if it's in contact with the ground, it's going to be producing a reaction force. So I've got that on the diagram. The driving force is coming from this rope that's angled at 50 degrees. The force in the rope is 13 newtons, and because it's a diagonal force, I can consider its components. So the angle here is 50 degrees, which means the components, the horizontal component is going to be 30 cosine 50, and the vertical component going up is going to be 30 sine 50. Okay, so these are going to be used in the calculations. We are told that the particle is accelerating, so it's in motion, and this is rough horizontal ground, so we are expecting some friction. We continue reading, and we're told that the friction has a magnitude of 1/10 r. So the coefficient of friction was 1/10. We're asked to determine that unknown acceleration. So let's go ahead and use our usual strategies. We're going to resolve both vertically and horizontally. Resolving vertically, there are three forces or components to make use of. We have r, 30 sine 50, and 15g. So since the particle is not moving in the vertical direction, that means it's in equilibrium vertically, so the forces up equal the forces down. So r plus 30 sine 50 is going to equal 15g. Okay, I can easily just rearrange this to get r as the subject, and just typing this into the calculator to three significant figures, we get 124 newtons. Resolving horizontally, well, since this is in motion, we're going to use Newton's second law as a motion equation. F equals ma. F in this case has to be the resultant force. We'll take the forces in the positive direction of motion and subtract the forces in the negative direction of motion. So we have 30 cosine 50, subtract the friction, 1/10 r. Yes, we know what r is. I'll substitute that in on the next line. This should equal the mass times the unknown acceleration, so 15a. We can solve for a by rearranging to make a the subject. We'll then get 30 cosine 50 minus 12.4, that's 1/10 of the reaction force, and dividing it all by 15. This gives us an acceleration of 0.459 meters per second squared.